Yeah, question one. We have thus limit of f of x as x tend to 1 exists for the function, have the function for the function f of x. These are the functions with the condition given. For the first function, x is less 1. For the second function, c, x is equal to 1. And for the third function, s is greater than 1. So if yes, find the value of c for which f of x is continuous at x equal to 1. The first thing first, what is the condition for continuity? For continuity, the limit of f of x as x tends to, since we are given 1 at x equal to 1, I'm going to explain that. At x equal to 1, the right hand side, that's a plus, must equal to limit of f of x as x tends to 1 minus, that's the left side, okay? And at the same time must equal to what? Limit as x tends to 1 of f of x. So, and for this one, this will be equal to what? We'll come back to this. This is equal to f of 1. So this is the condition for continuity. And look at what we have here. You can see the value is 1, 1, 1. So which one is the right hand side? Which one is the what? Left hand side. The right hand side is the value of x more than 1. This is x greater than 1. That will be for the right hand side of that limit of that function. And if you look at this one now, this is x less 1. Okay, for x less 1, that will be for what? Limit as x tends to what? 1 minus. That is the left side of that 1. And this is what? F of 1 when x is 1. So we have the function there. So let's go straight and apply that. So limit as x tends to 1 plus. So that's the function that is s greater than 1. So we have this function. Then you do your direct substitution. So this will be equal to, this will be 2 plus 3 minus what? Minus 19 all over. This one, ln of 1, that will be 0. So we have minus 7 there. Minus 14 over minus 7. And that's giving us what? 2 for the right-hand side. Let's get the limit of f of x as x tends to 1 minus the left side of that function. And that is what? That's this. Then do your direct substitution, and that will be equal to, if you do your direct substitution, we are going to have, this is 1 to power 10. That's 1. So that's 0. That's 1 minus 1. This one also be 1 minus 1. Anything 1 to any power is 1. That's 0. And that gives us indeterminate. Is that the end of the road? No. So when you have indeterminate, your indeterminate could be of this form and could also be of infinity over infinity. Okay? And that will call for the use of L'Hopital rule. And what we are doing in applying L'Hopital is very simple. We're going to differentiate the numerator, which is what? Which will be 10 x9 all over. We're going to also differentiate the denominator, which will be 5x4. And that will give us 2x5. That's 2. So we've gotten the right side of the limit. We've gotten the left side of the limits. And they're both equal. Okay, and that confirms the continuity, that the function is what? It's continuous. Then the last thing to do is to get the limit of f of x as x tends to 1. And that will give us the limit of f of x as x tends to 1. It's very straightforward. As x tends to 1, that's c. Okay, so let's apply these conditions and make the final conclusion and get the value of c. This one, they are equal, they're 2. So that means we're having 2 equal to what? Limit of f of x as x tends to 1, which is the same thing as what? F of 1. F of 1 is what? Is c. So c is what? C is 2. So that's that on this question 1. If you're new, you're watching me for the first time, what are you waiting for? there is a watermark on this video. Just click on it, subscribe, and begin to type your comments. You can forward your question, and I promise you I'm going to respond to your question as soon as possible. Okay, and finally, share the links of this video on all your social media platforms. Thank you for doing that. Question 2. Find the y, the x. For the a part, we have y equal to ln of x plus 3 minus what? Minus this function. Straight to the solution, the y dx will be equal to, for the ln function, it will be 1 over the inner function, x plus 3, and then times derivative of the inner function times 1. Derivative of x plus 3 is 1. So then minus this one, derivative of that is 1. And that finished the first part. The second part, the y dx is going to be equal to, this is logarithm to base 2. I'm going to chip in one or two things before going straight to the solution. If the logarithm to base 2, when you have your base as integer, positive integer, it's going to be 1 over the function you have here times ln of that base, okay? And then times derivative of the inner function. So I'm going to use d dx of that function, and then let's come back here, plus derivative of this one. This is a chain rule. For chain rule, the derivative of exponential function is going to give you that exponential function, okay? And then times the derivative of the power, d dx of this function. For exponential function, anytime you differentiate exponential function, it's going to give you times derivative of what? Of the power. This one is a chain rule. This expression is a chain rule. So it's going to be what? Times derivative of cosine is minus sine of that function, okay? And then times derivative of that inner power of that function, 3x squared. So that's that on this place. So just have, and then for this one, if you differentiate this one, CSC x is going to give you minus cosec x times cot x. So that's the derivative of CSC, and then plus what? Plus derivative of this exponential function. Okay, we now have the final conclusion, the y dx minus cosec x cot x plus exponential to power x all over this one. Okay, then derivative of this one is minus, we have minus what? Minus 3x squared, minus 3x sine x to power 3, and then exponential to power this. So that's that on this case. The thing is to be grounded. Actually, most exam will give you the table for your differentiations. Point I want to say, if you are new on this channel, quickly click on the watermarks on the video and subscribe. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for